Hello, in this video, I am going to discuss Cambridge IGCSE Physics Paper 2, May June 2024, Paper 21. Let us get started. Look at the first question. In which row are the quantities correctly categorized into scalar quantities and vector quantities? Now, to answer this type of question, you need to know what's the difference between scalar quantity and vector quantity. That's the basic thing that you need to know. You have to bear in mind that scalar quantity is about magnitude. Scalar quantity has magnitude only. Magnitude means the value together with the appropriate units, whereas vector quantities contain both magnitudes as well as direction. This is very important. Now, let us look at A. I am going to put out everything here for you just to make sure that you know everything about the physical quantities, which are scalars, which are vectors. Now, A, scalar. Okay, I'm not going to answer the question first. I'm going to do this one by one. Mass is a scalar quantity. Energy is a scalar quantity. B, gravitational field. Oh, okay, this is weight. Weight is a vector quantity. Acceleration is also a vector quantity. B, gravitational field strength is a vector quantity. Time is a scalar quantity. Force is a vector quantity. Electric field strength is a vector quantity. C, speed is a scalar quantity, whereas momentum is a vector quantity. Distance is a scalar quantity, whereas the force is a vector quantity. D, distance is a scalar quantity and energy is a scalar quantity. Let us look at velocity is a vector quantity, but the temperature is a scalar quantity. Now the question asks which are the quantities that correctly being categorized into a scalar and a vector. So the answer is scalar, scalar. These are vector, vectors. The answer is A. Question number 2, which name is given to the quantity of matter in an object? Now, what about density? Let us look at one by one. Density is defined as mass per volume. Mass, on the other hand, it represents the amount of the substance contained in our body. So that is why you have different mass, because you have different number of atoms in your body, because we are all solid, remember? I will have different mass from you because I have different number of atoms in my body. So this is the quantity. Yeah? Mass is the quantity, amount of the matter inside the body. Volume, on the other hand, what about the volume? Volume is about 3D, three-dimension thingy. If you consider, okay, maybe a cuboid, a cube, right? You want to find the volume, you just take the length times the for cube. You just take the length times the length and times the length. 3 times 3D, x, y, z direction. Whereas weight is the gravitational field acting on the body. Gravitational force. Gravitational field, gravitational force acting on a body. So if you want to know whether you have weight or not, try to fly without wings. You can rarely leave the ground unless you jump up a bit higher, but still eventually you come down due to the gravitational force on the earth that is acting on you that pull you downwards, right? So the answer is A. Number 3, a body is moved from place X to place Y, where the gravitational field strength is different. What happens to its mass and to its weight due to the move? The mass, remember, mass is always constant, no matter where you are, no matter which planet you go to, Jupiter, Saturn, Neptune, right? Or Earth, your mass will be the same. So mass stays the same. What about your weight? Due to the difference in the gravitational field strength, let us recall the equation for weight. Weight is equal to mass multiplied by gravitational field strength. Since the gravitational field strength is different and the mass is constant, your weight has to change. The answer is C. Number 4, the mass of an object is 2.5 kilogram. The volume of an object is 480 cm cube. What is the density of the object? Wow. This type of question, first thing you have to do is that look at the units of the density. The unit of density is gram per cm cube, and the unit of mass given is kilogram. So you have to convert the kilogram to gram. And if you do not remember the equation of density, it doesn't matter because there's another way to do it. Let's say you don't remember the equation of density. How do you do about it? First, let us look at this. The unit of density is gram. So you know that it has to be gram divided by cm cube. See that? So you just take the one number divided by the other number. Easy. Now, I just write down the equation of density for you. Density is equal to mass divided by volume. Mass must be in grams, so you have to convert your kilogram to gram. You take 2.5 kilo, you just times 100 because you want to convert it to gram. This is in gram over 480. Use your calculator to calculate that. You get 5.21 gram per cm cube. 5.21 gram per cm cube. The answer is B. Now, question number 5. Four objects each have two forces acting on them. Which object is in equilibrium? Do you still remember the conditions for a system or an object to remain in equilibrium? First is that the resultant force acting on the object must be equal to 0. Second condition is the resultant moment acting on the object must also be equal to 0. I look at A. It seems I find my resultant force first. For A, resultant force, one is 1 Newton towards right, the other one is 1 Newton towards left. Left and right are two opposite directions, so you have to put positive to one direction and negative to the other direction. So I put positive to right and negative to left. My resultant force will be 1 Newton plus negative 1 Newton, so 0 Newton. So A could be in equilibrium. I just put a tick first. What about B? B, resultant force, 1 Newton to the left, 1 Newton to the right. Put positive to the right, negative to the left. 1 Newton plus negative 1 Newton. B could be the answer too because you get 0 for a resultant force. What about C? 2. 1 Newton and 1 Newton are pushing the object towards right. There is no left hand side force to balance that right hand side force. So the resultant, since these two forces are acting in the same direction, so I just put positive to two direction, 1 Newton plus 1 Newton. So the resultant force is 2 Newton. C is definitely not your answer. What about D? I have 1 Newton and the other 1 Newton are acting in the same direction. These two 1 Newtons are acting in the same direction and they are pushing the object to the left. So I have to put positive to two direction, same direction. 1 Newton plus 1 Newton, I get 2 Newton. D is also not your answer. Now, to choose between A and B, you have to use the second condition, which resultant moment must be equal to 0. First of all, you have to set a pivot. For B, let's say I set a pivot here at the center of the object. For A, I do the same thing. For B, if you should remember the equation of moment, it is the product of force and the perpendicular distance between the force and the pivot. Now the force, let us look at this force first, 1 Newton to the right. Where's the perpendicular distance from the pivot? The perpendicular distance, because the force is horizontal, perpendicular distance must be vertical. This is what we call perpendicular distance. And this is, I put it as D1. I just take 1, okay. And after that, I need to identify whether it will cause the object to turn clockwise or anti-clockwise, right? 1 Newton towards right, while going to the right, it will have to turn towards a pivot. So it will turn down towards the pivot. So this is called clockwise direction. Okay. And the other 1 Newton, okay, let's say this is D2. Okay, moment, clockwise, right? I put this as clockwise. It is 1 Newton times D1. So it's just D1. Newton meter. What about the other force, which is I don't put it as negative because for a moment, I just need to identify the direction. So I erase this negative sign. For this moment, this is the force which is pushing the object towards left. And while going towards left, it will have to turn to meet this pivot. So it will turn in this direction. Let me show you. This direction. It is also in clockwise direction, right? So you have two clockwise direction, right? Clockwise direction is also 1 Newton times d2. So you have d2 Newton meter. There is no anti-clockwise direction to counter the clockwise direction. That is why B cannot be in equilibrium, because this object B will turn in clockwise direction. What about A? If I set my pivot here, where's my perpendicular distance from the pivot? I do not have any perpendicular distance from the pivot. That is why there's no moment acting on object A. Therefore, the answer is A. Number 6, a ball of mass M falls vertically and hits this hard surface. Let me draw it out easier. There is a ball and the mass is M and it's just falling with the speed of V1. It hits on the hard surface and then it rebounds. This is still M. Rebounds with speed V2. What is the change in momentum? So I put change in momentum. Remember, how do you find the change in momentum? It is equal to final momentum, mv. I just write down the general equation first, minus mu. Now, I want you to see this and I want you to think about it very, very carefully. Momentum is a vector quantity owing to the fact that velocity is a vector quantity. Why velocity is a vector quantity? You have to consider its direction. So you have to consider the direction of the velocity. Could you see that? This velocity is going downwards, initial velocity is going downwards, and the final velocity is going upwards here, right? So I have to put positive to one direction and negative to the other, opposite direction. Since I want my answer to be positive, I will put positive to the final velocity and negative to my initial velocity. Now I just put in, sub into the equation, m v2 minus m negative v1. So I want you to see this carefully. Open out the bracket, negative times negative, you get positive and v1. Factorize out the m, you get v2 plus v1. The answer is C. The next one, question number 7. A stone is dropped from a tall tower and falls a distance of 50 meters to the ground. The stone has a mass of 3 kilograms. At which speed does the stone hit the ground? First, if you see this type of question, you draw everything. Draw out, sketch out the diagram so that it's easier for you to see what is happening. There is a stone and the distance between the stone and the ground is 50 meters, or this is my stone. And the mass of the stone is 3 kilograms. At what speed does the stone hit the ground? So when the students see this type of question, they always get confused. They don't know what kind of speed they're supposed to use. I would suggest you, when you see a distance is given or height of a building is being given and they ask you to find the speed, right? Use the principle of conservation of energy. Total initial energy equals total final energy. Total initial energy of the stone is gravitational potential energy because the stone is at a certain height, which is 50 meters from the ground, which converted to kinetic energy of the stone when the stone is falling with a certain speed. Gravitational, now recall the equation of gravitational potential energy, which is mgh, is equal to half mv squared. In this case, I will cancel my m, not going to use m. G, 9.8, h is 50, which is equal to half v squared. To find v is 2 times 9.8 times 50, and you square root the answer. You should get 31.3 meter per second as your v. Now the answer is B. Question number 8, a coal-fired power station generates electricity. Coal is burned and energy is released. It's used to boil water. The steam from the water makes the generator move and this produces electricity. Which role gives the name of the energy stored in the coal and the energy stored in the moving generator? Now, for coal, because coal needs to burn, so that is chemical energy. Geothermal energy is the energy in the inner core of the Earth. Right? So the answer could be A or B. Generator. Remember generator? You have to turn the generator first before the generator can generate electricity. So that is turning is called kinetic energy. The answer is B. Question number 9. A man put some ice into water. Wow, warm day nowadays, right? I feel like drinking cold water myself. On a warm day, yes, this is true. After a short time, he notices that the ice disappears and the water droplets appear outside of the glass. That is also true. If you don't trust me, you can do the experiment. Which two changes of state are taking place? First of all, when the ice disappears, that is called melting because the ice has already changed state to water or liquid. That is called melting. So I can accept, okay, B or C. When the water droplets, right, the droplets of the water appear outside of the glass, it is due to the temperature outside of the glass, which is higher compared to inside of the glass. So some of the gas particles will condense, right? So that is called condensation. Condensation meaning to say that a changing of state from gas to liquid. Question number 10, gas of volume 200 cm cube is trapped inside a container by a piston. The piston is pushed to the right, Oh, pushing to the right, I draw it. So push to the right now. This is a new location of my piston. And the volume of gas decreases to 100 cm cube. Temperature of the gas remains constant. This is very important. Which row states the effect that this has on the kinetic energy of the gas particles and the force per area, which is pressure exerted by the particles colliding with the inside walls of the container? I would say that I have to say kinetic energy must stay the same. Why? Because the temperature of the gas remains constant. Right? Kinetic energy can only change when the temperature is changing. So it's either C or D. But since the volume of the gas is getting lesser, there is more frequent of collision between the gas particles and the inner wall of the container, which increases the force by gas on the inner wall of the container. Force per surface area of the container, which is equal to pressure, will also increase. So the answer is C. Now, question number 11. Which graph shows the relationship between pressure and volume of a fixed mass of gas at constant pressure? So you have to bear in mind, okay, for me, this type of question, how do I relate to the real life is that whenever I'm in a room, a big room, let's say a bedroom, I feel very comfortable. If you put somebody inside the room together with me and more people inside the same room, same size, I would feel more uncomfortable. I don't like more people inside the room. So this is about your private space. Do you get me? So when volume is lesser, if your room or you have to change or you change to a smaller room, how do you feel when you used to this big room? Right? So when the volume of the room decreases, I feel more stressed, right? Because it is hard for me to move about. I don't have a lot of space, so I feel more pressure, right? So that is why pressure will increase when the volume is decreasing. The answer is D. Now, question number 12, during evaporation of a liquid, the most energetic particles escape. That is very, very true. Temperature of the remaining liquid changes. Which row identifies where these particles escape from and describes the temperature change? First of all, to identify where these particles escape from, this is evaporation. Evaporation, the liquid particles can only escape from the surface of the liquid and no others. Right, what happened? Most energetic particles, meaning to say that, remember, most energetic means kinetic energy, or I just write down KE, high. High kinetic energy particles have already escaped, leaving behind lower kinetic particles. Lower kinetic energy, because kinetic energy can be related to temperature. Lower kinetic energy, temperature, directly proportional to temperature. When the kinetic energy is lower, the temperature would drop as well. Therefore, the answer is C. Question number 13, wet clothes are put out on a line to allow the water in the clothes to evaporate. Which type of weather would cause the water to evaporate most quickly? Actually, you can do this experiment yourself. Cold day, no, it is hard to dry the clothes. Do you think so? It has to be a hot day and with the wind. Do you know why? Because the wind will blow away all the evaporated air particles so that the other water particles will have space when they are being evaporated. Oh, question number 14 has been removed. We continue with question number 15. A solar water heater is designed to absorb energy from sunlight. Which surface texture and color would be best for the solar water heater? So if you want to absorb the energy, the best absorber of heat is dark color, right? It is black color, not white color. So that is why when you wear dark clothes or black clothes during a hot sunny day, you feel even hotter. Or like me right now, I feel very hot. But when you wear white color clothes, you don't feel that hot. White color t-shirt, right? And you want to absorb the most energy from the sunlight, it has to be dull black because shiny will reflect the heat from the sunlight. So A is the answer. Number 16, which statement about waves is correct? Now, let us see. Waves do not transfer either energy or matter. If waves do not transfer energy, then you can't possibly listen to my voice. Don't you think so? This is wrong. B, wave transfer both energy and matter. If that is true, when I'm talking to you, my mouth will go to you and I have no mouth. That is also wrong. C, waves transfer energy without transferring the matter. That is why I can keep on continue talking to you. C is correct. Wave transfer matter. No, cannot move my mouth from me. That is wrong. Therefore, the answer is question number 17, the angle of incidence of a ray of light incident on a plane mirror is gradually increased to the nearest degree. To the nearest, that means you might need to round it off. What is the maximum possible angle between the incident and the reflected ray? Now, I just draw a mirror. Let's say this is a plane mirror, and then this is my normal. Okay, now your angle, okay, this is what we call angle of incident, right? And then this is what we call angle of reflection. So the angle of incident must be equal to the angle of reflection, if you remember that. Now, what is the maximum possible angle? Okay, possible angle, I think, as long as it is not 90 degrees to the normal, maybe I take 89.9 or 0.8, 0.5, doesn't matter, 89.9, as long as it is not 90 degrees, right? So I take 89.9, which I draw it a bit out, degrees, and it will be reflected, it will be reflected at 89.9 degrees as well. Okay, so what is the maximum possible angle is that? Because this is from normal to incident angle is 89.9. 89.9 plus the angle of reflected ray, which is also 89.9 degrees. And then you end up getting, let me do it, 89.9 plus 89.9. You end up getting 179.8 degrees. You know that final answer, we cannot accept 1, 2, 3, 4, 4 significant figures. That is why you round it off to 180 degrees. So D is the answer. Now, question number 18, which conditions are necessary for light to be totally internally reflected? Total internal reflection. This question is asking you, what is the condition or what are the conditions in order for the total internal reflection to occur? First condition, incident ray must be coming from a denser medium. A denser medium. So incident light must be from denser medium. So C or D could be the answer. And the angle of incident must be greater than the critical angle, right? Not C. It is greater than the critical angle. That is why the answer is D. Because when the incident angle is equal to the critical angle, light would be refracted at 90 degrees. What is critical angle? Critical angle is the angle of incident that causes the light to be refracted at 90 degrees. Question number 19, the diagram shows a ray of light passing from air into a transparent substance. What is the refractive index of the transparent substance? Right, to find the refractive index, N is equal to sine I over sine R. In this case, I use sine I over sine R because light is traveling from less dense medium to denser medium. But if light is traveling from denser medium to less dense medium, you have to use sine R over sine I. Sine I is sine 40, is the angle of incident. Yeah, angle of incident is the angle between incident ray and the normal. What is normal again? Normal is just an imaginary line which is 90 degrees to the surface of the air and the transparent substance. Right, so this is sine R is sine 30. So when you work it out, you should get 1.29 as your answer, which is B. Now, question number 20, the diagram shows a ray of light in an optical fiber. Which statement correctly explains the condition for the maximum transmission of light by the optical fiber, right? So the glass must slow the light as little as possible to make the critical angle for the fiber as large as possible. Slows the light as little as possible to make critical angle as large as possible. If the critical is larger, then the total internal reflection could not really occur, right? Because as long as if the critical angle is smaller, then it is easier for light to be reflected internally. So I don't want my critical angle to be as large as possible. I want it to be as small as possible. So critical angle as small as possible, yes. Critical angle as large as possible, no. Critical angle as small as possible. So it's either B or C, B or D. Let us look at B. The glass must slow the light as little as possible to make the critical angle. Right? I don't want to slow the light as little as possible so that I could make my critical angle as small as possible. Let me write down the equation for refractive index, 1 over sine C. So if my critical angle is as small as possible, the refractive index will be as high as possible, right? So refractive index can also be calculated as the speed of light in air, which you cannot change, is fixed, and speed of light in glass in this case, because optical fiber is made of pure glass. So when the critical angle is as small as possible, 1 over sine, a smaller number, it will give you a larger refractive index. So larger refractive index, it will actually give you small speed. So you have to, this glass must slow the light as much as possible to make the critical angle as small as possible, which is also true. Or I combine these two equations. How about that? 1 over sine C is equal to V, the speed of light in air, divided by the speed of light in glass. So one is a number is constant, V is constant as well. So sine C is directly proportional to the speed of light in glass. So I want my sine C to be as small as possible. That is why the glass, okay, must slow down the light as much as possible. This one must be slow down, go down, slow down as much as possible, right, in order for my critical angle to be as small as possible. That is why the answer is D. Number Number 21, which region of the electromagnetic spectrum is used for detecting fake banknotes? Nowadays, a lot of fake banknotes. What do you think, right? The answer is ultraviolet. It is like violet ray that you can see directed onto your notes. Question 22. A sound wave travels at 330 meters per second. Distance between the center of compression and the center of nearest rarefaction in the sound wave is 2.5 cm. What is the frequency of the sound wave? Now, this is really tricky question. You know, sound wave consists of a series of compression, rarefaction, compression, rarefaction, and compression, and rarefaction again. The distance between the center of compression to the center of the other neighboring compression, this is called wavelength. The distance between the center of rarefaction to the next center of rarefaction is called one wavelength. Now, the questions say this is a distance between the center of a compression and the center of nearest rarefaction. Rarefaction is here. So center of compression to the center of the nearest rarefaction, this is half of the wavelength. Therefore, you have to be extra careful. Half wavelength is 2.5 cm. Therefore, the wavelength is equal to 5 cm. You have got to change it to meter. Look at the unit of your speed. This is meter per second. So lambda is equal to 0.05 meter. Then use back V equal to F lambda, equation of waves, speed of wave, which is 330 is equal to frequency times 0.05 meter. Frequency is equal to 330 divided 0.05. Let me do it. 330 divided 0.05. The answer is 6,600 hertz. C is the answer. Number 23, which waves are used in the medical scanning of soft tissues? Soft tissues, scanning of the soft tissue, that is called ultrasound. Ultrasound, right? Number 24, which row describes suitable materials for use in a temporary magnet and in a permanent magnet? Temporary magnet is the magnet that could be magnetized and demagnetized easily. That is, of course, soft iron. Permanent magnet is a magnet must be made of hard magnetic material, which is not easily to be demagnetized once it is being magnetized. So that is called steel. B is the answer. Now, 25, a magnetic field is represented in the diagram by magnetic field lines. At which point is the magnetic field strongest? You want to see whether the magnetic field is the strongest or the weakest? You look at the separation between the magnetic field lines. So A is the answer because the separation is the closest one as compared to B, C, and D. Question number 26, a student determines the resistance of resistor R. She uses a circuit including a voltmeter and an ammeter. Which circuit does she use? Now, look at A. A cannot be your answer because ammeter and voltmeter are being connected in series with the circuit. It doesn't work. B, ammeter and voltmeter are connected in parallel to the main circuit. This is not possible. It's not working. C, the voltmeter is connected in series with the main circuit. You won't get any reading as well. Ammeter must be connected in series with the main circuit. In series, that means beside the positive terminal of the battery or beside the negative terminal of the battery. Voltmeter, on the other hand, must be connected in parallel. That means you got to get extra wire to connect to 2 points that you want to measure the potential difference. That is why D is the answer. Question number 27, a diode and a resistor are connected across a variable DC supply. Terminal X is initially positive. Positive, terminal Y is negative. And it is at the maximum value. Potential difference PD across X and Y is adjusted so that it changes as shown by the graph. Look at the PD across X and Y, it decreases to 0. So what is the function of this diode here? It only allows the current to flow in one direction only. So when X is positive, it will basically block the current from flowing through the resistor. So there is no current flow initially until it is equal to 0, still 0. So A cannot be the answer, B cannot be the answer, C cannot be the answer. Oh, I look at D, no current flow until when the current of X is negative and the current of Y would be, or Y would be more electropositive, then only it will conduct electricity. It will let the current to flow, but in a negative manner. So D is the answer. Now, question number 28. When a conductor in a complete circuit cuts across a magnetic field, a current is induced in the conductor. Which statement about the induced current is correct? A, induced current is in the same direction as the motion of the conductor? No. Because based on Lenz's law, the direction of the induced current is always opposing the direction of producing it. This is wrong. A is wrong. B, the induced current is in the opposite direction to the motion of the conductor. It is not the motion of the conductor that causes the current to be induced. It is the change in the magnetic field, right? So this is also wrong. C, the direction of the induced current is in the same direction as the magnetic field. That is not possible. D, the direction of the induced current opposes the change that causing it, which is true. D is the answer. Now, question number 29, the diagram shows a solenoid carrying an electric current. Which row compares the strength of the magnetic field due to the solenoid at points Y and Z with the strength of the magnetic field at point X? Now, point X and point Y are inside the solenoid. So the magnetic field inside the solenoid will be uniform. Uniform meaning to say that the magnetic field is constant inside the solenoid. So for Y, right, the magnetic field is equal to X. But from Z, it is further away from the solenoid. That is why the magnetic field is a bit weaker. So it's a bit lesser as compared to X. A is the answer. Now, question number 30, a conducting wire is placed between the poles of a magnet when an electric current in the wire is in the direction shown. Then the force on the wire acts out of the page. Three statements of different conditions and how the wire is affected are given. Which statements are correct? We are going to look at this one by one. When the current is towards the top, going up, of the page and the direction of the magnetic field is unchanged, right? Only one change. Only one change. You change the direction of the current, the direction of the force would change. One change causes the other change, right? So this is true. Second, when the current is towards the bottom, yes, and the magnetic field is reversed. Okay, this one will become South Pole, this has become North Pole. Only magnetic field is being reversed. One change, right? It will cause the force to change. Second point is also correct. Now, third, when the current in the wire is alternating, the wire vibrates into and out of the page, which is also true because the current changes the direction. So the wire, the current changes the direction, so the magnetic field will also change the direction. So when the magnetic field produced by the wire is changing direction, it will cause the force to change the direction as well. So the third one is correct. A is the answer. Question number 31, which types of electric current are in the primary coil and the secondary coil of a step-up transformer? Now, to draw a step-up transformer, this is what I call step-up transformer. I am going to draw it. This is, okay, a little bit uglier. I hope you can accept that. This is soft iron core. I call this as primary coil. This is connected to AC supply. And this is a secondary coil. Step out, so secondary coil must, coil must be more as compared to the primary coil. This is called step-up transformer. So now, for the electric current, transformer can only work with AC, so the primary coil will be AC. Secondary coil, because the current, causes the magnetic field to be AC as well, varying magnetic field. That is why the current produced in the secondary coil will be AC as well. A is the answer. Number 32, a scientist fires alpha particles as a very thin sheet of gold and detects the particles that pass through. Which statement about the results of the scattering experiment is correct? A, alpha particles are attracted to the nucleus. No, no, no. If alpha particles are attracted to the nucleus, then you won't see alpha particle coming out. You won't detect alpha particles anymore. So A cannot be the answer. B, half of the mass of the atom is concentrated in nucleus. Why half but not all, right? That is wrong. C, most of the alpha particles are deflected, showing that the nucleus is very dense. If most of the alpha particles are detected, I want you to imagine this. You have a thin piece of facial tissue. You use a machine gun. You try to fire the machine gun. You could see that all the bullets are flying in all directions. That is not possible, right? Right. This machine gun, the bullets of the machine guns are like alpha particles. So not most of the alpha particles are deflected, only some. D, only a small number of alpha particles are deflected, which is true, but some of these are deflected through large angle. That is also true because when the path of the alpha particles are closer to the nucleus, it will deflect even more. 33, notation represents the nucleus of a gold atom. Relative charge on a proton is +1. What is the relative charge on the gold nucleus? The charge of the gold nucleus is based on the charge of the gold atom. So you have 79 atoms, 79 times -1, you get 79 positive 79. A is the answer. Number 34, an isotope of hydrogen has the nuclide notation 21H. How many neutrons are in the nucleus of this isotope? And what's the relative charge on the nucleus? The charge on the nucleus is basically based on the charge of the proton. So you have one proton, +1. What about neutron? Neutron, you just take nuclear number, which is 2, minus proton number. You will get your number of neutrons, which is 1. A is the answer. 35, a radioactive source is placed near a detector. Radiation arriving at the detector from the source is measured for 10 minutes with different materials placed between the source and the detector. Which type of radiation are emitted by the source? So I will see when none, this is about 5,626. And when I put a sheet of paper, it doesn't seem to block the radiation. So that is why, because alpha particles can be blocked by a few sheets of paper. So there's no alpha particles from this. A and B are wrong. It's either C or D. When you place a thick sheet of aluminium, remember beta particle will be blocked by aluminium. There is a significant drop, yeah, between reading detected by the detector. So there is our beta particles. When you put a thick sheet of lead, you could still detect radiation. That means that's gamma ray. Because basically there's nothing on Earth that can stop gamma ray. We can reduce gamma ray. So C is the answer. Number 36, the reading on detector placed near radioactive material is 536 counts per second. Background radiation count rate is 44 counts per second. Half-life of the radioactive material is 34 hours. What is the reading on the detector after 68 hours? When the background radiation is given, no choice. You have to go for corrected count rate. You have to calculate that. How do you calculate that? So you take the reading, initial reading by the radioactive material, counts per second minus the background count rate, which is 44 counts per second. And you get 492 counts per second. And then 492 counts per second is the initial count rate of this radioactive material. So I use table form to do it because it seems to be easier. So I started at, this is for radioactive material, 492 time is equal to 0. When it decreases to half of its initial value, which is 246 counts per second, this is one half-life, right? One half-life, which is 34 hours. And then when it decreases again by half to the reading of 123 counts per second, this is 2 times the half-life. So you take 2 times 34 hours, you get 68 hours here. So take this value because this is the reading of the radioactive material. This is the corrected count rate, or this is a real count rate of the radioactive material after 68 hours. But hey, look at the question again. What is the reading detected on detector? The reading detected by the detector must included with the background rate, the background count rate. So reading on detector is equal to 1, 2, 3 counts per second plus with the background radiation, background 44 counts per second. That gives you 167 counts per second. D is the answer. Beware with this type of question. Number 37, a planet in the solar system is at the point in which orbit where it is closest to the sun. Which row is correct? Remember the principle of conservation of energy, right? So when the orbital speed is at its maximum, the energy in gravitational potential, store has to be at its minimum because there is interchange between only two energies. One is kinetic energy, the other one is gravitational potential energy. So orbital speed, that means the speed is maximum. So which leads to maximum kinetic energy. So when the kinetic energy is maximum, gravitational potential energy must be minimum. B is the answer. 38, what is the main process that powers the sun? Burning of helium and oxygen, that is no. A burning of hydrogen, who's going to burn that, right? Hydrogen and oxygen, who's going to burn that? Say nuclear fusion of hydrogen to form helium. Yes, exactly. Nuclear fission of helium. How can nuclear fission occur to helium? Because helium is also a small particle. Fission can only occur to big, large particle. Okay, number 39, a galaxy is 3 times 10 to the power 20 kilometer from the Earth. At which speed is the galaxy moving away from the Earth? Remember Hubble constant? H naught is equal to the speed of the galaxy that's moving away divided by the distance between the galaxy and the Earth. Hubble constant is 2.2 times 10 to the power negative 18 per second is equal to V, which you have to find, divided by, oh, this is kilometer. I have to, I put it in terms of kilometer first, just in case that I have the answer. So I put 3 times 10 to the power 20. If I don't have the answer from kilometer per second, then I will change it to meter. So V is equal to 2.2 times 10 to the power negative 18 times 3 times 10 to the power 20. Let me do it. 2.2 times 10 to the power negative 18 times 3 times 10 to the power 20, you get 660 kilometer per second. Thank God I got the answer, which is A. So I do not need to convert to meter. Right, number 40, an astronomer observes a distant galaxy. The table shows how the distance and speed of recession, recession meaning to say that the galaxy is moving away from the Earth, right, are determined. Which row is correct? The distance. How do they determine the distance, right? It is actually from the brightness of a supernova. What is supernova? A super duper bright energy release, right? Due to the date of a star, right? In the galaxy. Yes, this is true. Change in the wavelength of the starlight from the galaxy. Redshift, remember? Speed of recession, yeah, is due to the change in wavelength, which is redshift. Therefore, the answer is A. Now, we have done with all the discussion for all 40 questions that appeared in your major 2024 paper 21. I hope you find benefits in this video and do support me by subscribing to my YouTube channel. Thanks again for watching. See you again in my next video. Bye.